Okay, let's start. Just a minute. So today we're going to practice the IUPAC naming. Now we are just writing the word root. We have just written the rules only. Na?
Yes, sir.
Yes, we have written the only the rules. So let's start. Just is the screen is visible to you now?
Yes, sir.
Yes, sir.
So let's start. So today we'll be going to discuss that is isotopes. Sorry, the IUPAC namings. We have done this one. In the previous class, we have written the. Today we'll be going to discuss the functional group and how to write the IUPAC name. We're going to discuss, and today we're going to learn the isomers and what are isomers and how we name them. Okay, so let's start studying. Okay, just IUPAC naming. I talk about IUPAC naming. So what is actually IUPAC naming if I talk about? Okay, so IUPAC in IUPAC naming we just used to write the names. Okay, so first of all, we in an IUPAC name we have first of all we have a prefix, then a root, prefix, then a root, then a saturation indicator, and then finally we have suffix. Prefix, I told you it can be or can't be. Okay, it can be more than one, or if it is present, it can be one or more than one. Prefix, we generally write the name for those functional group like chloro, like bromo, like iodo, okay, like nitro, or a branch for alkyl group. Alkyl group for a branch, like for one carbon chain, we use methyl. For two carbon chain, C2H5, we use ethyl. Okay, ethyl. For three carbon, C3H7, for we use propyl. Okay, NO2, nitro, chloro, bromo, iodo, fluoro is root we have written in the previous class that for one carbon we use meth. Okay, meth. For two carbon we use eth. For three carbon we use prop. For four carbon we use bute. For five carbon we use pent. For six carbon we use hex. For seven carbon we use six carbon we use hex. For seven carbon we use hep, oct, and so on. So for saturation indicator, if there is carbon-carbon single bond everywhere, I'm just talking about carbon-carbon, not carbon-oxygen. Mark my point. I'm just talking about carbon-carbon, not carbon-oxygen. So when I'm just talking about carbon-carbon, okay, here, then it will be, tell me, it will be, we use saturation indicator as A and E. Okay, if we have double bond between carbon-carbon atoms, then we use E and E. And if we have triple bond between carbon-carbon atom, then we use Y and E. Because for alkyne, this stand for alkene and this stand for alkane. Okay. And suffix, we write for the functional group like for OOH, COH. If we are going to have COH as a functional group anywhere, we use oic acid because it is carboxylic acid. So its suffix is oic acid. The second one is, I'm just revising this one. Okay. We have done this one all in the previous class.
Yes,
Next
sir.
one is aldehyde is CHO. We use al for it. Okay. For ketone, we use ONE. For if I talk about
Alcohol.
alcohol. So L for
OL.
alcohol, we use O
OL. OH.
O L. Okay. OL, all. And you need to keep in mind that all these prefix, suffix, sorry, they are having vowel words. Okay. So when we are just adding this with this one, then we will replace this E. Because if there is no prefix, sorry, if there is no suffix, then we will use ANE, like propane, propane. Okay. But if I'm just writing propanol, propane, then we'll use all. We will remove this E here. Okay, because two vowels cannot be written. Okay, first we have a vowel, then a consonant word. Okay, and two consecutive vowels are not there. There is no rule for writing the two consecutive vowels words. Okay, in English. So that's why if these vowels, these are the vowels. These all start with vowels. So we will remove this. Okay, in order to write the IUPAC names. Just for practicing, write the IUPAC name of this one. Okay, I'm just not writing the hydrocarbon. If it is written, it can be written like this: CH3, then CH. If this carbon has make bond with three other carbon atom, so only one hydrogen will be there. Why? Because this carbon has made bond with this carbon and this carbon and this carbon. So only a carbon can make maximum four bonds. So are you getting my point? So this will be CH3. Got it? Got it? Then CH2.
Yes, sir.
CH only. Why? Again, this is also connected with 3. 1, 2, and 3. This is CH3. Okay. And this is CH3. So what should be the name for this one? There is no suffix, there is only prefix. Okay. So first we will write the prefix, then root, then saturation indicator, and then suffix. Okay. This suffix is not present here. Why? Because there is no alcohol group present. Okay, no carboxylic acid, no aldehyde, no ketone. Prefix, if I talk about prefix, this is CH3. Got it?
Yes, sir.
So we have what we are going to have rules. There are different rules we have written. So here, first of all, we will select the longest carbon chain. So this is the longest carbon chain of 4 carbon. Then the second rule was that right numbering should be done in such a way that the functional group should get the lowest possible number. So if you write the numbering from here 1, 2, 3, 4, then this is functional group is at 2 and 3. And if you write it like this way 1, 2, 3, 4, then again the functional group is at 2 and 3. So you can use any way. Okay, both are same. If you write like either this like this way or either from this way. Okay, so what should be the name for this one? First of all, we will write if there is more than same prefix is present, same prefix. This is CS3, this is also CS3. If there is more than one same prefix is present, then we use di, tri, tetra before their name. What we use? Di, tri, tetra before their name.
Name.
Okay. So we'll write, first of all, we write the number. What's the number? That at 2 position, comma and 3. When we have two numbers, then there should be a comma between them. And when we are writing a number and a alphabet, English word, then there should be a dash between them. Okay, this. So we'll use 2 comma 3 dimethyl, dimethyl, because at 2 position and 3 position we have dimethyl. Now prefix is over. Now we have to write the root. Prefix is written. Now we have to write the root. The root for this one is 1, 2, 3, 4. There are 4 carbons. We will use for bute. Once we have written the capital letter, now we are just going to write only small letters. Okay, without this. Okay, then bute. Then root is done. Then saturation indicator. There is single bond everywhere in the carbon. There is no double bond. So we'll use A and E. There is no suffix. So we'll use E also. Okay, butane. So 2 comma 3 dimethyl butane is the name for this one. Got it? Got it?
Yes, sir.
Okay. Okay. Note this one and then try to write the name of this compound. Write the name of this one. Write the name of this compound. Try to write the name of this compound.
So,
Yes.
so can you tell me what is the IUPAC name of the compound C2H5OH?
C2H5OH. Correct.
Yes.
This is ethanol. I will
What,
explain.
sir?
Ethanol.
Ethanol.
Ethanol. Yes. We will discuss this one. First of all, tell me what's the name of this compound? What's the name of this compound? So first of all,
So,
numbering should be done in which the functional group should get the lowest possible number. This is the main functional group. Okay, first of all, select the longest carbon chain, including the functional group. So this is the longest carbon chain that we have selected, including the carbon with which functional group is attached. Okay, so 1, 2, 3, 4. Okay, at 2 position we have methyl group. We first write prefix because we have written here that at prefix is either chloro, bromo, nitro, or any chain like CH3, C2H5, any branch. Okay, so here we have branch. So first of all, its name should be written, and first of all, we write its position. So at 2 position we have methyl, 2 methyl. Then first English. Okay, it's not necessary that you have to write this capital letter. You can write it small letter also. Okay, got it? Got it? So what we
yes.
are going to do here is, let me first of all. First of all, we will do the numbering. Numbering should be done in such a way that the functional group should get the lowest possible number. Okay. So the carbon with which, if the functional group has its own carbon like COH, then its carbon should be given the lowest number. Okay. And this carbon should be in the chain also. This carbon should be in the chain also. You need to keep in mind that this carbon should be in the chain also. Okay. Got it?
Yes,
Yes,
sir.
sir.
Okay. And
Yes,
if the
sir.
functional group does not have carbon, like OH does not have its own carbon, then the carbon with which functional group is attached, like this carbon is attached with this one. Its structure is like this. Okay. We have 4 carbon. Here we have CH3 like this. This we have CH3 like this. Here we have CH2. We have hydrogen here. Okay. We have CH2 here. And this is OH. So this carbon with which functional group is attached, it should be in the chain. So this is in the chain. Okay. Now, what should be the name of this one? What should be the name of this one or this one? You can write it that first of all, you will write the prefix. So prefix is this one. This is the chain. Branch is considered to be, means we write the name of branch in the prefix. So its position as is 2. So we write 2 methyl, 2 methyl. Got it? Got it? 2 methyl. This prefix is over. Now this 4, now the root. 1, 2, 3, 4. After prefix, root is there. So what is the root for 4 carbon? Root word but. Then there is single bond between carbon carbon atom, then ane. Okay, got it? Butane. And then we don't write E here. Why? Because we have suffix. So if it is the first position, then we will write all. Butane all. Got it? All. And if it is not, okay, are you getting my point? If it is not, for example, if it is present here at the 2 position, then we will write 2 all. But if it is present at the first position, then we don't write 1 all. Okay. So this is the name for this one. Got it? Note this one. 2-methyl butanol. Note this one.
Sir, is C2H2 a saturated hydrocarbon?
What are you saying? If
Is C2H2 a saturated hydrocarbon?
C2H2,
Yes, sir.
where is C2H2 written?
No. I'm asking. Is it
You're
a
asking
saturated
C2
hydrocarbon?
H2 is H2. No, it is not. It is unsaturated. It is ethyne. Okay. Note this one. Have you noted? Tell me, have you
Yes.
noted? Should I move forward?
Yes, sir.
Yes, sir.
Okay, so
So we are just using very easy one. This is which is very means which is being asked in the examinations or means we you need to know. Okay. So this one, first of all, tell me the name of this one. This one. Tell me the name of this. Tell me. What should be the name of this one?
So,
Yes, tell me what will be the name?
first one is ethanol, right?
Yes, it should be ethanol.
Yes, sir.
Okay, it should be ethanol. So eth. Why eth? Because there is no prefix. You can
Yes,
write it
sir.
CH3, CH2OH, and this simply can be written in compressed form C2H5OH, and
And second one is
it can be further written in more compressed form that you will going to learn in this when we will doing the question. It can be written C2H6O. It can also be written like this. Okay. So what is this formula? It can be written as CH3 CH2OH. It can be written as C2H5OH. It can be written as C2H6O. So for there is no prefix here. Okay, there is no prefix. The longest carbon chain is of 2 carbon. So that's why we use eth. There is single bond between carbon atom. We'll use ane. We will remove E and then we use ethanol. Ethanol. Okay. What should be the name of this one?
propanol.
Propanoic.
Okay. Prop,
Yes, sir.
propanol, not propanol.
Propanoic. It's
Propanoic
carboxy.
acid. Prop for 3 carbon. Prop. This
And
carbon should be
ONE.
calculated. This is functional group carbon. This should be
Yes, sir.
calculated in the chain. Okay. Number 1, 2, 3. Prop. Then
Oh,
ane.
one. Yes, sir. E
Okay.
cancel and then OHOL.
Then oic acid. Because it is carboxylic acid. COH is carboxylic acid. It is its structural form is COH like this. This and this both are same. Got it?
Okay, sir.
Next, what's the name for this one? What should be the name?
Sir, it's ketone group, right?
So is it propanol?
What are you saying?
Is it propanol?
Is it propanone? Yes, it is propanone. Okay. Yes, you are right. It is
So
propanone.
because like three, so prop and then say, ONE and OL.
Yes, ketone is actually this is the simplest ketone. For ketone, at least we need 3 carbon. I have told you in the previous class, ketone can only be found by 3 carbons. Okay, at least 3 carbon. Like ethanol, ethene, methane, you can form with 1 carbon, 2 carbon, but ketone can be prepared by 3 carbons. Because if you put this as a termination carbon, like I'm just having, if you put the double bond here, okay, and this is 2 carbon, okay, and you have the written like CH3, okay, okay, we know because this is ketone group CO. And if you put this H here, then this will become aldehyde. CHO, aldehyde. So at least this should be carbon. This should be carbon. So at least 3 carbon should be there. Okay. Got it? So this is
Yes.
ketone. And ketone functional group again name is prop for 3 carbon, 1, 2, 3. And then ane for carbon carbon single bond. You can see here that we have carbon and oxygen double bond, but still we need to write it on. Okay. Got
Yes,
it? So here is we just write it ane. Why? Because we just check the carbon carbon single bond, not carbon oxygen. And then sorry, on.
yes, sir.
Propane. Okay. What should be the name for this
Sir,
one?
ethane.
Ethene, because carbon carbon single bond is there.
Yes, yes, ENE.
Ethene.
Double bond.
What should be the name for this one?
Sir, it's
Ethine.
INE. Yeah, ethine.
Yes, ethine. And what should be the name for this one?
Propanol.
This is propanol.
Prop for 3 carbon and then
And
ane
single
for
bond
single
and
bond.
OHOL. OH.
Propanol. Okay. So this is the way that we are just going to write this one. Now we shall be moving towards the next is isomerization. And what are isomers actually? Isomers are the compounds of hydrocarbons having same molecular formula, okay, but different structural formula. Okay, got it? They are going to have different structural formula. For example, what are isomers? Let me explain you. So here we have, okay, here we have. So what are isomers? These are the compounds of hydrocarbons having same molecular formula but different structure or structural formula. You can write it structural formula. Okay, like for example, let me explain you this. You can explain. We can explain it in many ways. Okay, so let me explain you here. That for example, if I write a formula here, C4H8O. Okay, C4H8O. So it can be written like this: C4H8. Okay, how count the number of carbon? 4. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8. 8 are the hydrogens. Okay, and how many carbons are there? 1, 2, 3, 4. Got it? How many carbons are there? Sorry. How many how many oxygens are there? 1. Got it? So if I talk about this one, that in this one, which is going to have C4H8O. Okay, C4H8O. This, and we can write the same formula for this one. So what should be the name for this one and this one? Tell me what should be the name for this one and what should be the name for this one. Here actually also we have 1, 2, 3, 4 carbon. Hydrogen is 1, 2, 3, 4, 5, 6, 7, 8 and oxygen. They both are going to have the same formula, but they have different structures. Even we can say they have different functional group. In this one, we are just going to have ketone as a functional group. And in this one, we are just going to have aldehyde as a functional group. So can you tell me that which one is going to have? Can you tell me what should the name of
First
this
one
one?
is butanol.
Butane. Butane. Tell me butane.
ONE.
Not ONE. This is ONE. This one is ONE. This is ketone,
Oh,
na?
but it's double one O, right?
No. We just always check double bond O. This is aldehyde functional group, okay? And it should not be aldehyde functional group is always
Okay, sir.
means it is always placed at the termination.
Yes, yes, yes.
Okay, this is not the keto. This is aldehyde. CHO is aldehyde. This is aldehyde functional group, okay? Aldehyde functional group. And this one, if I talk about this one is butanone. Butanone. Okay. So they both are going to have the same functional group, sorry, same molecular formula, but they have different functional. Okay, so they are known as functional isomers. So there can be different types of isomers. Like we have chain isomers, chain or branch isomer. Okay, chain isomers. Isomer, if I talk about what is the difference between chain isomers? Like for example, if I write C5H double of this one, okay, and then add 2, it is 5, 10 into 12. Okay, means we have general formula for alkane. Alkane general formula is CnH2n plus 2. So if we write C5, then double of this one will be 5 into 2
1
plus
plus 2.
this will be
12.
C5H12. So you can write C5H12 like this: CH3, CH2, CH2, CH3. Okay, not this is only 4. No? CH3, CH2, 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 CH3. You can write it like this way. Split is going to have pentane only, pentane. Okay. You can write it like this way: CH3, CH. You placed one. You just remove one carbon. I'm just placing this one. First, I'm just writing the carbon only. It's 4 in the main chain, and you just take one branch. You can write CH3. This carbon has only 2 bonds, so this will be CH2. This carbon has 3 bonds, only 1 hydrogen. This has only 1 bond, so this is 3 hydrogen. This is only 1 bond. This is only 3 hydrogen. So what should be the name of this one? Tell me. What should be the name of this one? Tell me. This is very simple, na? You can check it. First of all, you have to number this one. There is no functional group. Only this branch. So branch should be given smallest number 1, 2, 3, 4. Okay. This branch should be given. If you start doing like this 1, 2, 3, then this will get 3. So this is the only correct way to number. Okay. Now you write 2 at 2 position. What you have going to have a branch. Name of this branch is methyl. 2 methyl. Because this is CH3 and CH3 is methyl. And then you have how many carbon in the longest carbon chain? 4. So you write bute. In. Okay. Got it? 2 methyl butane. Got it?
Yes, sir.
Sir.
Yes, sir.
Okay. Now, if you write this one, what's the formula for this one? We have C5, 5 carbons. Total counted total number of hydrogen. 3, 3, 6, 3, 9. 9, 10, 11, and 12. Again, these two are known as, this type of isomers are known as,
19.
yes, this is pentane, and these are the isomers of pentane. This is pentane, and this is the isomer of pentane. Okay. So we can say that pentane can be C5H12 can be written like this way. You can further write it in different manner. Okay. You can write it like this way. Like 4 and 3 in the main chain. Okay. And then just 1 here and 1 here. Okay. Like CH3, 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 and then CH3. Still it is C5H12. Okay. Why we cannot place like this? 1 carbon here and 1 carbon here. Because again, this will become the longest carbon chain of 4. And at second position, we will going to have, mean this and this is same. This is 1, 2, 3, 4, and at second position, we have one CH3 group. Okay. Got it? So this
Yes.
is, what should be the name of this one? Select the longest carbon chain again. Select the longest carbon chain. Why don't we have put hydrogen here? Because this carbon has made 4 single bond. So there is no place for hydrogen. Now what should be the name for this one? Tell me. What should be the name for this one? So first of all, we have at 1, 2, 3. So at 2 position, we have one CH3 group here and one CH3 group here. So we write 2 at 2 position and another also at 2 position. Means at 2 comma 2 means at 2 position and at another at 2 position. We have dimethyl. Okay, dimethyl. And then propane. Propane. Okay. Got it? Got it?
Yes, sir.
So let's start with this one. That what is isomers? Please note it down that what are isomers. This is very important topic of this chapter. Okay. These are the compounds of hydrocarbon having similar molecular formula but different structural formula. Okay. Note this one last. What is positional isomers? In which the position of the functional group is changed. For example, here, if we note this one, it is at the first carbon. This OH group is written at the first carbon. So its name is propaneol. And if we place this at the second carbon, then its name should be propane 2-ol. When it's two position, we are just going to have on. So this is known as positional isomers. It is at the first carbon, 1, 2, 3. Okay, but it is at the second carbon, 1, 2, 3. If you do it numbering from like here, 1, 2, still it is at 2. So at 2 position, we are going to have, okay, alcohol. So it is propane 2-ol. Okay, like here, this is 1, 2, 3, 4. This is at first position, we have 1 chloro, 1 chloro, 1, 2, 3, 4, butane. And here it is 2 chloro, butane. With that 2 position, we will do numbering from here 1, 2, 3, 4. Why we do the numbering from here? Why not from here? Because if you do it from here 1, 2, 3, 4, okay, then it will be, got it? It will be, means chlorine is going to have get filled. So we will do the numbering from that position from where it get the lowest possible number. So note it down fast. Noted? Tell me done.
No, sir.
Noted fast. Compounds of hydrocarbon having same molecular formula but different position of functional group.
Done, sir.
So let me explain you one more time that there are different types of functional group. What are isomers first? Isomers are those compounds of hydrocarbons which is going to have the same molecular formula but different structural formula. What is explaining? Okay, there are different types of functional group. Okay, one is sorry, there are different types of isomers. The three we are just going to have, we just going to study in this 10th standard. There are other forms also, but we don't these are not in our syllabus. Okay, like okay, so there are different types of isomers also, but we are just going to study three only. So one is the positional isomers, in which the position of the hydrocarbon is different. Okay, like sorry, position of functional group is different. Like this one, in this one, here the alcohol group is present in the first carbon, but here in this one, okay, the alcohol group is present in the second carbon. Both are going to have the same number of carbon and hydrogen. Its name is propanol. Why not we are just writing one all? Because we don't write one, like when if it is written 5/1, we write it like 5. Okay, we don't write the divisor if it is going to have one. Same thing is that it is also understandable if it is the position is not given, then it means it is understandable that it is at the first position. If it is at the second position, then we have to mention the position of the functional group. So its name is prop for 3 carbon in carbon-carbon single bond, and 2 all means at this all group is present at the, it means alcohol functional group is present at the second carbon. Similarly, this one 1 chlorobutane and this one is 2 chlorobutane. So these in this the functional group is going to have the different positions. Okay. Next type of isomers is chain isomers or branch isomers. Here, this is very important. This is also being asked in the examinations, and most of the time, chain isomers is being asked in the examinations. Okay, so same molecular formula, but difference in the means difference in the main carbon chain number. Okay, so they are going to have the same molecular formula. For example, butane, if I'm talking about. Okay, let me explain you one more thing here that chain isomers can only start with 4 carbon. Minimum 4 carbon should be there. There should not be like in the means why it cannot start here, just because if you remove this carbon and if you want to make the chain again, if you either you can put it here or you can put it here. So again, this is the 3 carbon chain. So it is start with the 4 carbon. Minimum 4 carbon should be there. For function for branch isomers, there should be 4 carbon. 4 carbon, the simplest alkane is butane. Butane. Okay. So this is CH3, CH2, CH2, and CH3. Got it? Got it? And this one is 1, 2, 3. Okay. Now check the 3 carbon. Okay. Main chain should be 3 carbon. And now the rule is that if you are just taking the 3 and now you have freed 1 carbon. You have taken the main chain of 3 and you have freed 1 carbon. You cannot put the 1 carbon, sorry, the carbon at the termination or the starting one. Means at the end or this one you cannot put. Only the choice is that you can put in between. So only there is 1 carbon in between, so you can put it here. Okay, got it? Got it? Here it is going to have CH3, it is going to have CH3, it is going to have CH3, and this is going to have CH only. Now you can count it. It is C4H10. 3, 3, 3, 9 and 1, 10. Here also 3, 3, 6 and 4, 10. Both are going to have the same molecular formula C4H10. And here is also C4H10, but they have the different names. Here its name is 2-methyl. At position 2 we have methyl group and then propane. This is its IUPAC name. This is its IUPAC name. But here we just have the common name also for this one. The common name for this one is isobutane. Just keep in mind that isobutane is the common name. And in the common name, we use the total number of carbon. We don't write here isopropane. We write isobutane. The total number of carbon should be counted. So this is the common name. This is the common name. Got it? Got it? This one is butane and its common name is N-butane. N-butane means normal butane. N stand for normal butane. So there are only the two isomers of two chain isomers or branch isomers of butane. Okay, got it? There are only two. We're just talking about butane. Got it? Got it?
Yes, sir.
Yes, sir.
Okay. The next one is if I talk about pentane. The pentane we have done C5H12. We have pentane. Pentane has three isomers. One is normal pentane. CH3, CH2, 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 CH3. This is normal pentane. And its IUPAC, this is N is IUPAC. So this is common name. And its IUPAC name is only pentane. This is IUPAC name. IUPAC name. Okay. Pentane. Now just take the 4 carbon chain and make it 1 carbon free. So you cannot put the free carbon here or here. They are not. Means you cannot put at the first, because if you put it here, again it will be 5 carbon chain. If you put it here, then again it will be 5 carbon chain. So you cannot put the removed carbon or the carbon that you have taken from the chain to make the isomers, to make the chain or branch isomers. So you cannot put it at the termination carbons or the first carbon. Okay. So either you can put it here or you can put it here. If you put it here, okay, if you put it here, then it will be 1, 2, 3, 4. The numbering should be done from this one, this side. And if you put it here from, if you put it here, then the numbering should be done from here. So either if you put it 1, 2, 3, 4, either if you put it here, the numbering should be like this. So both this and this are same. They are exactly same. They are exactly same. Okay, they are exactly same. Exactly same. They are not different. So we will consider them as one. The another. This is the first one and this is the second one. Either you draw this structure or either you draw this structure. What should be the name for this one? The name for this one is at 2 position we have one carbon chain. The one carbon chain name is, tell me, what is the name for the one carbon chain? Speak. What is the name for the one carbon chain? Prefix for the one carbon chain?
Are you asking like ANE?
No, one carbon chain. Alkyl group for the one carbon. This is CH3 group. Let me put the hydrogen here. CH3, CH3, CH, CH2, CH3. So what should be the name of this one? Tell me what should be the name for this one? Methyl.
Yes,
One chain.
methyl butane.
Yes, it is 2 at 2
Uh,
methyl.
yes, dihyd
Then butane,
butane.
2 methyl butane. Okay, got it. And here also this both are same. It is also 2 methyl butane.
Yes, sir.
Okay, so either you write like this way, either you write like this way. It is counted as a one. Okay, so this is 2 methyl butane, but it's common. This is its IUPAC name, but its common name is iso butane or pentane. Isobutane or pentane, tell me. So you need to keep in mind that in common name we write a total number of carbons 1, 2, 3, 4, 5. So this is isopentane.
Pentane.
Okay, isopentane. But in the IUPAC name we wrote the longest carbon chain. Got it? This is the second
Yes,
isomers. The third isomers for this one that we have drawn for this pentane is, okay, like if you have, means if you put it like this way or this way, now another you cannot put here, you cannot put here. Either if you put it here, then it will be like this. If you put it here, it will be like this. So there is no other isomer in the, as if you have taken the 4 as a main chain. Now if you put it like this way, you have freed the 2 carbon. Now if you put it like this way, let me explain you that the 2 carbon you have freed, the 2 carbon, if you have freed the 2 carbon, got it? So you can put it the both like this, but it will be considered as long. Okay, you cannot put the 2 carbon because at termination you cannot. Okay, at termination you cannot put it. Okay, at termination carbon you cannot put it. Why? Because if you put it, then it will counted as in the longest carbon chain. Again, it will become 4. So out of 5, you have the 3 in the main chain and 2 you have freed. Either you can put 2 like this, one chance is this one. Here, this and this carbon you cannot put it. Or you can put it 1 carbon here and 1 carbon here. Okay. Just imagine if you put the both carbon like this way, then this will be counted as the longest carbon chain. 1, 2, 3, 4. Now it has become 4 carbon chain, which is like this. And at second position, we have a branch of 1 carbon. Like this, and this structure is same, exactly same. This is same. So what we need to do, this will be corrected as incorrect. So we will put 1 here and 1 here. Got it? 1 here and 1 here. So what should be the name for this one? It should be 2, comma 2. 2, comma 2. Like we have written 2, comma 2. We have just taken this longest carbon chain, and this is CH3, and this is also CH3. Okay. And this is also CH3, and this is H should be, this is CH3. So we have 2, comma 2 means at 2 position, and at this 2 position, both are at 2 position. Okay, both are at 2 position. Like you can do the numbering 1, 2, 3. If you do the numbering like this way, it is also at 2. Now this will be considered as longest carbon chain. Now this will become branch. Okay, you cannot select the chain like this. No, the chain should be in a straight line. Okay, so once you start, if you go it like this, you can go like this 1, 2, 3, then this 2 will be considered as a branch. So you can select any if you are going to select it in any way, then you are going to have only 3 carbon in the longest carbon chain. So here you can write it, you can select it like this way. Okay, and this will 2 at 2 position and another also at 2 position. Both the functional group, if they are even on the same carbon, then you have to write their position. Okay, at 2 position, another also 2 position, we have dimethyl. When there is more than one same, then we write dimethyl propane. Okay, got it? Got it? Note this one also. Done? Noted?
Yes, sir.
Okay, so how many isomers do we have? Tell me. Of butane, we have pentane, we have 3 isomers. And okay, and what is the common name for this one? Common name is neopentane. Common name is neopentane. Neopentane is the common name for this one. Okay, so note this one. Just here you can note it. Just let me explain. Okay. This, have you noted all the 3 isomers of this one and the common name also for the pentane? Tell me, everybody in the class.
Yes, sir.
Okay. Next is, now draw the isomers of hexane. Try to draw the isomers of hexane. Okay, hexane. Try to draw it by your own. Try to draw the isomers of hexane. Then I will help you. I'm going to give you 5 minutes to make the isomers of hexane. C6H40. Okay. CH3, CH2, 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 1, 2, 3, 4, 5, and 6. Try to. There are 5 isomers of hexane. Try to draw all the 5 isomers. Okay, try to draw it. Done. Drawn this one. Drawn the isomers of this one. Tell me fast.
I did too.
So this is hexane. Simple hexane. Then just remove 1 carbon. Free 1 carbon. Take the main 5 carbon chain. Okay. Now you cannot put. Okay. This is the hexane isomers. Okay, and it's very simple. You can draw. What the funda here is that what you need to do is just write the first simple hexane, then just remove 1 carbon. And you cannot put that carbon at the termination now. The position is here or here. Now, either you can put it here or you can put it here. Okay, you have freed 1 carbon. You can either put it here or if you can put it here. If you put it here, then the numbering will start from here. 1, 2, 3, 4, 4, 5. Okay. And if you put it here, then the numbering will start from here because this carbon is going to get the 2 position. If you put it here, it will get the 2 position. And if you put it here, then it will get the 2 position. So it can be means they both are same. If you put it here, they are not considered as different. If you put it here, this will be the same as this one. So you can select anyone. Okay, they both are same. Like if I'm drawing here, it's 1, 2, 3, 4, 5, and if I put it here. If I put it here, then numbering will be done like this 1, 2, 3, 4, 5, and this will be 1, 2, 3, 4, 5. So the name for this one is 2-methyl pentane. Okay, and here is also 2-methyl pentane. Then next, what you can do is you can put it here at the 3rd position. This carbon in the main 5 carbon, you can put 1 here. So 1, 2, 3, 4, 5. So this is 3-methyl. This will be 3-methyl because this will be 1, 2, 3 and position has been changed now. So this is 3-methyl pentane. Okay, there is no other way that if you are having the 5 carbon main chain and you can put it. If you put it here at 4, it will be considered the 2nd position. So this is in the main 5 carbon chain. If you are taking the 5 carbon chain for making the isomers of hexane, then these are the 2. Only these are the 2. Okay. One is this one, another one is this one. Okay, so these are the 2 isomers. Next, now take the 4 carbon as a main chain, 4 carbon. Okay, 4 carbon. When you take the 4 carbon in the main chain, then you have freed the 2. The rule is that you cannot put the 2 togetherly. You cannot put the 2 together. Okay. You can put it one upon and one below this one. Okay. This is not the rule that you can put it like this way. Okay. Up to where we are just going to have in your syllabus. Okay. Only 7 or 8. Means only up to hexane it will be going to ask in the examination. No, heptane will not be asked. So only hexane isomers can be asked. Okay. So you cannot put it on this termination. You have freed the 2 carbon. Okay. You have freed the 2 carbon and you cannot put it at the termination. So what you can do here is that this is 1. You can put it like this way, the 2 carbon on the same one, or another chance is you can put it one here and one here. One on this carbon and one on this carbon. If you put both here like this way, both the same on this way, then this and this will be same. Because here the numbering will be done like 1, 2, 3, 4. Here the numbering will be done 1, 2, 3, 4. So what should be the name for this one? Tell me fast. What should be the name of this one and this one? To start doing numbering like this, 1, 2, 3, 4. What should be the name of this one? Tell me.
So first one is 2-methyl and butane.
2,2 dimethyl. 2,
Yes, sir.
2
2,2 dimethyl butane.
dimethyl butane. Okay, and this one?
This one.
This one is 2,2 dimethyl butane. So at the this one is at 2 position. This one is also at 2 position. So we write 2,2 dimethyl. Here we have at 2 and 3. So we write 2,3 dimethyl methyl. Sorry, butane. Got it? Got it?
Yes, sir.
So 2 in the previous one and sorry 3 in the previous one. 1, 2, 3. This is the first one. This is the second one isomer. This is the third one isomers. Okay, and these two are the fourth and fifth. These are the and you in the examination you have to write the hydrogens also. Okay, like we have not written here. So you have to write the hydrogens also. Otherwise it will be considered as incorrect. Okay, write the hydrogens. So this has made 3 bonds. So there will be only one hydrogens. 3 hydrogens like CH3. There is no hydrogen. All hydrogens has been there. Okay, so you have to write it like this way. Got it? Got it?
Yes, sir.
Okay, so 2,2 dimethyl butane and 2,3 dimethyl. We have just 5 isomers. There are 5 5 chain or branch isomer of hexane. Put it down. Okay.
Done, sir.
Done.
Yes, sir.
Okay, next. Everyone done? Done this one?
Yes, sir.
Now we have functional isomers. Note it down, functional isomers. The definition of functional isomers. So what is actually functional isomers? Let me explain you. What is functional isomers? The compounds of hydrocarbons having same molecular formula but different functional group, like we have done in the aldehyde and ketone. Like we have this can be written as C3H6O, and same if we have aldehyde. Okay, this what's the name of this one? What's the name of this one? This is propane al, and this is propanol. Okay, propanone. Sorry, propanone. So they both are going to have the different. Okay, So we say the functional isomers, the compounds of hydrocarbons having same molecular formula but different functional groups are considered to be as functional isomers. Okay, note it down. Means different functional group but same molecular formula. Note it down, please. And that's all for today. We'll meet you in the next class, okay? We'll discuss this one in the next class. Hello, Namir. How are you? Is I'm audible?
Hello.
Hello, Namir. Is I'm audible to you?
Yes. Yes, sir.
Okay, just starting in 1 minute, okay? 1 minute. Just wait.
Sir, is there an assessment today?
Today? No, you
Sir.
don't have. No. Today we don't have this assessment.
Okay.
Yeah. So that's all. We'll meet you in the next class. The students can leave.
Okay, sir. Thank you.